When a mathematical relationship between two variables is implicitly defined, we don't have one of the variables solved on a side by itself, we can use implicit differentiation to still find the derivative of one variable with respect to the other. Now when they ask us to find dy dx, they're telling us within the notation that our dependent variable is the y, the one that's in the numerator, and the independent variable is the x, the one that's in the denominator. So when we're differentiating an implicitly defined mathematical relationship, we need to make sure that we still apply the chain rule when it's necessary. And so if we have an action on the dependent variable, once we do the derivative of the outside operation, we need to multiply by the derivative of the inside with respect to your independent variable, or in this case, dy dx. So basically, when we're differentiating this, we need to use our appropriate rules of derivatives of the differentiation process, but we also need to, with using the chain rule, whenever we're differentiating the variable y, we need to multiply by dy dx, or whichever your dependent variable is for that particular question. So let's look at this equation. I have in this first term, I have two terms on the left side and one term on the right. In the first term, I have a multiplication between two variable expressions, so I'll need the product rule there. Then plus, going to another term, I have a constant 5 times my variable x, and then equal, on the other side, I have a constant term, 32. So when I'm taking the derivative, I'll need to use the product rule in this first part. So I have my first factor x times the derivative of the second factor. The derivative of y squared is 2y, but it is our dependent variable that we've differentiated with respect to. So by the chain rule, I also need to multiply by dy dx. And then plus my second factor, y squared, times the derivative of my first. And my derivative of x is just 1. And that is my independent variable, so we have it where it's the direct derivative. I don't have a chain rule application there. Plus, the derivative of 5x is just 5. And then my equal sign, the derivative of a constant term, 32, is 0. So once we have this and we want to rewrite it a little bit, multiplication here is commutative, so I can change the order. I have 2xy dy dx plus y squared plus 5 is equal to 0. And I want to solve for dy dx. So I look for all the terms that have dy dx in it. The first term is the only one that has a dy dx in this problem. And then any term that doesn't have a dy dx, I want to move to the other side. So I have 2xy dy dx is equal to negative y squared minus 5, subtracting the y squared and subtracting the 5. And then now I just need to divide both sides by the 2xy to get the dy dx on a side by itself. So dy dx is equal to negative y squared minus 5 all over 2xy. So there you have an example using implicit differentiation.